Okay, so we have our orbit targeting oligo design app open for the E. coli MG1655 genome, and we are greeted again by GalK. Let's go ahead and jump to HisA, and again we have it set to a deletion oligo. So we have this deletion where we're deleting HisA. And now if we click on this integrating plasmid output tab, let's see what our actual locus structure should look like. Okay, and what you can see here is in gray are these same genomic positions. So HisH, HisH. HisA is now gone and is replaced with the orbiting integrating plasmid as well as the at sites. So this little at B site here, at BL and at BR, is this at B site breaking in half and recombining with the corresponding at P site on the integrating plasmid. So this locus has HisH, then it has HisA deleted, replaced by at B and the orbit integrating plasmid. And finally, this integrating plasmid is currently pointed in the plus or forward direction. You can see that because the CAN resistance gene and the origin are pointed to the right or forward, and things are oriented left on left and right on right. Okay, if we go back to targeting oligo design, if we instead point the at B direction to minus, and again, this refers to the genomic orientation, not the actual sequence that you order in the oligo, which is totally dependent on where you are in the genome. But if we switch it from forward to minus, the only thing that changed was the direction of this at B site. So now it's the reverse complement. And now the plasmid is pointing minus. It's pointing this direction. Okay, so that is what we mean by minus and plus in the at B direction. It determines the direction of the integrating plasmid from the genomic perspective. Okay, and this is important because, for example, if you are trying to check for this deletion in this locus structure, you might want to use these sequencing primers, for example, PN-seq reverse and PN-seq forward, paired with a primer in the genomic locus, for example, HisH and PN-seq forward. And so this orientation matters, and you certainly want to know what type of locus you're making. The other thing to notice here is that there was a gene downstream, HisF. This is an intentional design decision that I made when constructing the app, which is that you can see the deletion of HisA as it is currently shown overlaps with HisF and disrupts it. That is why it is not displayed here, because it is supposed to give you a clue that that gene is no longer intact. Now, if you wanted to adjust that, we could come here into the TO browser and move that thing forward, just upstream, and now HisF will appear. The other thing that is available to you in this window is you have a drop-down menu to select from some of the common integrating plasmids that we have made available on AdGene and tested in the Orbit paper. Of course, there's different resistance plasmids, for example, AMP resistance. There's also the plasmids used to make markerless and scarless deletions. For example, this one has both SACB and the excisionase that reverses the integrase process. It's not important the details here, but you can see that this app is responsive to both this dropdown and the targeting oligo parameters set here. Okay, other than that, this plot is static. You can just hover over it, but you're not browsing or doing anything in this window. The other things to note here are down here. You may have to adjust the window to see this table, but this table has a written version of what is displayed in the plot with the actual sequence information, which is useful. But most importantly is you can click Download BASTA, which will output the entire sequence, underlying nucleotide sequence that you see here. And you can import that sequence into your favorite DNA editor, such as Benchling, Snapgene, or APE. And then you can use the annotations that are listed in this table or download them as a CSV file and annotate that entire locus with all the detail you want, design your own colony PCR primers, etc. And of course, we recommend that you sequence your locus to validate it before using. So that is how you should interpret your integrating plasmid output based on your targeting oligo design in this web app. And the final video in this series will be about advanced and potentially troubleshooting issues using this app.